Carboxylic acids are named by counting the number of carbons in the longest continuous chain, including the carboxyl group, and by replacing the suffix "-ane" of the corresponding alkane with ionic acid. If there are two COOH groups, the suffix is expanded to include a prefix that indicates the number of COOH. It is not necessary to indicate position of the COOH group because this group will be the end of the parent chain and, and its carbon is automatically assigned as C as 1.
The carboxyl group takes the precedence over alkyl group and halogen substituent as well as the double bonds in the numbering of the parent chain. If the carboxyl group is attached to the ring, the parent ring is named and suffix carboxylic acid. When both double bonds and carboxyl groups are present, the "-en" suffix follows the parent chain directly and the OIC acid follows. If there is a choice in numbering not previously covered, the parent chain is numbered to give the substituent the lowest number at the first point of difference.
To name dicarboxylic acids, we add the suffix "dioic acid" to the name of the parent alkane that contains both carboxyl groups. The numbers of the carboxyl carbons are not indicated because they can be only at the ends of the parent chain. When a carboxylic acid also contains an alcohol, we indicate the presence of the OH group by adding the prefix hydroxy. When it contains a primary amine, we indicate the presence of the NH2 group by amine. IUPAC names. We derive the IUPAC name of an acyclic carboxylic acid from the name of the longest carbon chain that contains the carboxyl group. Drop the final E from the name of the parent alkane and replace it by oic acid. Number the chain beginning with the carbon of the carboxyl group. Because the carboxyl carbon is understood to be carbon 1, there is no need to give it a number.
Carboxylic acids are like alcohols. They form strong intermolecular hydrogen bonds. Most carboxylic acids exist as dimers held together by two hydrogen bonds. This strong hydrogen bonding has a noticeable effect on boiling points, making carboxylic acids boil at substantially higher temperatures than alkanes or alcohols of similar molecular weight. Carboxylic acids are polar because they are both hydrogen bond acceptors and hydrogen bond donors. Carboxylic acids also participate in hydrogen bonding. Smaller carboxylic acid which has 1 to 5 carbons are soluble in water than 6 or more carbons because of the hydrophobic nature of the alkyl chain. Carboxylic acids are the most common type of organic acid. It is a Bronsted-Lowry acids because they are proton donors. It is classified as a weak acid, meaning that they only partially dissociate in H cations and RCOO anions in neutral aqueous solution.
Esters are one of a number of compounds known collectively as acid derivatives. In this, the acid group is modified in some way. In an ester, the hydrogen in the COH group is replaced by an alkyl group, or possibly some more complex hydrocarbon group. Example 1. Methylpropanoate. An ester name has two parts, the part that comes from the acid propanoate and the part that shows the alkyl group methyl. Start by thinking about propanoic acid. A 3-carbon acid with no carbon-carbon double bonds. The hydrogen in the COOH group is replaced by an alkyl group, in this case a methyl group. Example 2. Ethyl ethanoate. This is probably the most commonly used example of an ester. It is based on an ethanoic acid, hence ethanoate, a 2-carbon acid. The hydrogen in the COOH group is replaced by an ethyl group. Make sure that you draw the ethyl group the right way around. A fairly common mistake is to try to join the CH3 group to the oxygen. If you count the bonds if you do that, you will find that both the CH3 carbon and the CH2 carbon have the wrong number of bonds. Acyl chlorides as acid derivatives. A carboxylic acid such as ethanoic acid has the structure. There are a number of related compounds in which the OH group in the acid is replaced by something else. Compounds like this are described as acid derivatives. Acyl chlorides, also known as acyl chlorides, are one example of an acid derivative. In this case, the OH group has been replaced by a chlorine atom.